You had a question, so hold that thought. Okay, I don't have a whole lot to go over today. So, first of all, what did we learn yesterday? What was our major, or not major, but was our objective, you could say, yesterday, to learn about this new concept? Yeah, and that's right, a force times a distance. Now, in this case, some of you are looking at that problem, maybe have it solved already. Distance, a height is also a distance because you're moving it from perhaps the ground to up above where it's actually needed. So yes, height and distance are, in this case, the same thing. Okay, so what is work measured in? It's measured in joules. What is force measured in? And then distance could be meters, kilometers, but in this case, probably the most common number you're going to use is going to be meters. Okay? So this was your new formula that some of you had wrote down. Okay? And then one of the things that you have to calculate before doing horsepower, that is the most common, let's say, I don't want to say variable, common way of measuring power. Yes, we talked about light bulbs yesterday, utilizing watts, but when it comes to machinery, okay, if you are going to buy something that is bigger for recreational purposes or buying something bigger equipment-wise for your farm, the machinery is getting bigger, so you have to buy something bigger to pull that piece of equipment, okay? So if you are running a 30 or 40-foot disc that requires 300 horsepower, well, it's recommended that you have a tractor that has 300 horsepower, but the current tractor you have is 270. Okay? Does that mean that you can't pull that piece of equipment? The answer is no. It can probably pull it, but maybe just not very efficiently. I think it would be a way of looking at that. Okay? Because, not that you would do this, but if you have a horse trailer or a recreational camper, on the camper, there's going to be a label on there that says the weight of it. And it's 5,000 to 5,500 pounds. You can look in your owner's manual for the pickup that you have, and it might say towing capacity of maybe 7,000 pounds. Okay? You can pull that camper or whatever it is that you're trying to tow, but it might not be very efficiently. Now, for those of you who maybe do that, not just the engine would you possibly be putting a lot of strain on, but when you're trying to pull something down the road, there's no way you would know this. I'm just trying to, let's say, make you think about this. It's going to put strain on the engine, that's true. Not just the transmission, what else? Maybe the tires. I'm not saying that I'm right and you're wrong, because that's accurate too. But I'm thinking, how does power get with the transmission? I understand that. You're correct when you say that. But how does power get from the front of the vehicle to the back? Did you say drive chain or drive line or probably the drive shaft, the crankshaft, any one of those. But the heavier equipment that you try to pull, you're not only just putting more strain on the engine and the transmission, but also your drivetrain. That's what we want to say. It's going to put more strain on your drivetrain. Okay? And one of the things that we talk about, we're getting a little ahead of ourselves, but I have mentioned that before. Okay? How many of you have, let's say, run a snowblower that's on the back of a tractor? Just one? Okay? So what happens is, how tall approximately is that snowblower? Well, okay, but that gets fed into the hopper. Let's put it that way. How about we say 4 feet? 4 feet, maybe by 5 or 6. Okay, so you've done it before. Are you driving forward or backwards? Okay, so you're driving backwards in your tractor and you're looking back, okay, and snow is continually being fed into that snowblower. Well, what happens if you got too much snow in there? The tractor's PTO is trying to drive that, it's too much, and all of a sudden it stops. It's locked up, but why does that not, this is a really critical thinking question, but why does it not damage your equipment? It's locked up, you're not wrong. Something's engineered to break so you don't damage your equipment. It's a type of pin. And when I tell you, you're going to say, oh, I knew that. There's a type of bolt that's engineered to break if there's too much strain on it. Anybody? Okay. You ever heard of a shear pin? Now, just an experiment, because I see that among students all the time. Do we really know what the shear pin is? Okay. So what happens is there's two wheels on here. Then there's a pin that goes between them. That's called a shear pin. But as that is rotating, if there's too much strain on there and it's starting to lock up, okay, that pin then shears. This is going to keep spinning. Your PTO keeps going, but your equipment has stopped. Now I just look like an idiot, like anything's like every other day, maybe. I don't know. Stop what? Oh. Okay. Oh, sorry, I didn't hear what we said, but what happens is that will not allow damage to be on your equipment, because once you've sheared in, that will cease all motion on there. Especially how many people we have run a baler before? Okay, is it a square baler or a round baler? Okay, so is what we're talking about sound familiar? Have you ever heard of a shear pin? Have you ever sheared a pin before? Maybe. Where you're, okay, so you're driving along, yes?
I think with my dad last year, did shear a.
Okay, so you're driving along, all of a sudden you hear some noise, and all of a sudden your baler stopped working. That sounds accurate, okay? Maybe, do you know what it was? Was it a rock?
I think it might have been a rock, or I think we got something stuck in it.
Okay, so that's designed to do that. So once that rock gets wedged into your baler, it's putting stress on there. That pin breaks, the PTO keeps going, but it won't do any damage to your baler. Okay, I have a feeling this might be getting boring, so let's move forward then. power, okay? You still are measuring work when we're talking about power, okay? Because here it tells you work is divided by time, okay? So power equals work divided by time. And this is more so maybe of a history question. Do you know how farmers used to clear fields before machines? We're talking about wheat. Wheat was, say that again? No, but they want to harvest it to keep the wheat. Yeah. Okay. Those things, do we happen to know what those things are called? I think you call them size. Okay. Not S-I-Z-E, but I don't, is it S-C, I don't even know how you spell it. S-C-Y maybe? Okay. So what would happen is, since humans are not machines, okay, well, you might say, gosh, I'm a machine. I'm here to impress the girls so I can lift 300 pounds at a time. Sound familiar, guys? You want to try to lift 300 pounds at a time? Okay. Let's just not hurt ourselves. Okay. So, you know, I think, I just want to make this quick point, because sometimes we try to make this a little more interesting. Okay. Who's the quarterback for Philadelphia? Anybody know?
I love him.
Jalen? Jalen Hurts. A commentator had said, now I don't know if this is accurate, he can squat 600 pounds. Okay, so I don't know if that's accurate or not. But if you ever watch Philadelphia play, if they're in a third and short or a fourth and short predicament, or they do a quarterback sneak, because what you have is Jalen Hurts trying to drive through because he can lift this 600 pounds on his back. Like I said, I don't know how accurate that is, but I think that's pretty phenomenal. But back to these size, okay? It's something that farmers used to do this, okay? So it would take a long time to do that. So we talked about McCormick's Reaper yesterday. That was a machine that would knock down the wheat, okay? And it did it very quickly. So it may take a group of, let's say, maybe 10 farmers, and I have no idea, I'm just trying to speculate, maybe 10 farmers, maybe 3 or 4 days to clear 25 acres. Again, I don't know how accurate that is. But what about, last thing I'm going to say, and we're going to continue with this. What about square bales? Does anyone still do square bales? Yep. Okay. So let's say you don't have the rack behind you. You're just pulling the baler along. You're putting all them square bales. They drop in the field. You got to pick them up. So call how many friends to go pick them square bales up. Okay. So did that go by pretty quickly?
Oh yeah, I was just driving and they did.
But does it work quick for them?
Oh, no, probably not.
Okay. But one of the things that takes a long time to pick up all them bales in a field. Okay. Some pieces of equipment you can probably use a loader tractor only to pick up a whole bundle at a time. I think there's some types of balers that are designed to do that. Again, I don't know how accurate that is, but let's just say it is. Again, we're not machines. That's because we get tired. Okay? If we were a machine, we would never get tired. Okay, so we will make sense of this in just a moment. Okay, so back to this problem. To complete construction, a crane is used to lift, okay, heavy I-beams. Of course, the reason we call them I-beams is because when you look down the end, I know this isn't entirely accurate, but it looks like an I, just like that, okay? So if the machine uses 30,380 joules and the mass is 3,100 kilograms, because of gravity, what is the height that that crane is lifting that I-beam? Okay, so this is a problem that's a little different. You've read the problem. What is the next thing you should do? So what do we know in this problem?
Mass equals 3,100 kilograms.
What else do we know? I caught that. It's not right.
33.
Okay? And that, of course, is joules. Okay? Do we know anything? I only see two numbers, but we need more information.
The acceleration is 9.8.
Why are you right? Because it says because of this. And what is the question ultimately asking for?
What's the height?
Height, which is also, we said earlier, a distance. Acceleration equals 9.8 meters per second squared. So we are looking for this. Okay? So when you look at your formulas, what does work equal?
Force times.
But we don't have the force, do we?
5.
But we can find the force. How do we know that?
Mass times acceleration.
Because these two variables here will give you your force. Okay, so therefore, we've got work. Oops, that's not right. Force, not work. We've got force equals what times what?
Mass times acceleration.
There's our mass, and of course here's our acceleration. So our force equals what?
That's not our mass. Our mass is 3,100.
I looked at that, didn't I? Okay, so now we've got our mass times our acceleration, which is what?
Oh, it's 3,038.
30380. Okay?
Yeah, that makes sense.
It doesn't make sense because I did this problem as we were walking in. We've amended this problem here. Okay? I had inadvertently just put the force in here. I did not put the work. So we can avoid this answer now, or this variable, because we've accounted for that now. Okay? The force is still the same. That's the right number. Okay? Now, if we have our force, now what can we do? What does work equal? Okay, so we have our work, 455,700 equals our force, 30,380 times what? What do we have down here? D, or distance. So how do we get letter D all by itself? You're going to divide the two, and what do we get? Okay?
We do meters? Or inch meters or centimeters or feet?
Meters. Okay? Unless otherwise stated, it's going to be in meters. Okay?
What's power measured in?
Watts.
Watts? So it's
Okay?
W?
Now, careful when this is work. I would do that. Power equals force times distance over time. You know why that is?
What? On our slide said power equals W divided by T.
That's correct. But what does work equal? Isn't that what work equals? Okay?
So do we have to write FP?
You can do that, or you can do, oops. Yeah, those mean the same thing. Okay? So force times distance is work, correct? Oh. Put a line over it. Yep. Just put a line over it. So you don't get it confused with momentum. That's right. Over this. Okay? Because when we're talking about this is what power is measured in, is in watts. Okay? So you could do the same thing here. Power equals force times distance divided by time. All right. Okay, we'll try to help you out. What part?
No, it's not a big deal. I get it now.
Oh, okay. Well, that was quick. Yeah. All right. Is there anything else? Front row, are we good? I understand it was a little rocky there for a moment. We appreciate your patience. Second row. Second row. Third row. All right. So we will catch up to you next time. I'll have a paper for you tomorrow to work on. It's due on Tuesday.